percentage change is a really important aspect of report writing, and it comes up in all the three internal reports that we do. In every case, it's always the change as a fraction of the original amount, or where the point that you started. And a classic example, you have a salary of $100,000, it goes up to $120,000. That's a change of that's a change of $20,000 out of $100,000, because that was the starting point. So that's a 20 out of 100, or 20% increase in salary. Or you could talk about a decrease in salary. You started at $100,000, you got decreased to $60,000. That's a change of $40,000, and the original starting point was $100,000. So 40 out of 100, that happens to be 40%. In terms of a percent change in peak value, which is what we're talking about here in time series, if I use no, I don't want that one. Not animate, skip animate. All I want is a time series plot. There we go, time series plot. We could look at the percentage change in the peak values. We could also look at this percentage change in the trough values. To do that, I need to find the maximum peak value and the minimum peak value. So if I point to it with the mouse, that would probably be that one there for maximum, and probably this one here for minimum. You can see here how rough the scale is. So you're probably going to be better off doing this in the lab and looking at the raw data. But if you forgot to do that, there wouldn't be any harm in approximating. Okay, so that might be 13.5. I think it's million square kilometers of sea ice, and that might be 12 square kilometers of sea ice. So that's the change. Now, so 12.5 out of, so 12.5 minus 13.5 minus 12 is 1.5. Out of what? What would the original be? The original is the maximum one, because the trend is a decreasing one. Right, so the highest peak, the original one would be 13.5. Now if I can find the window with the raw data, we'll find it. That one. For Arctic, and that was the one I was just looking at, we have to find, and this becomes difficult when you're looking at 12 periods per season. It's easier to do this with 4 periods per season, because you can straight away pick the right month in that quarter or in that year. But the actual peak is 13.44. There it is. Okay, can you see any higher than 13.44? Okay, so that's the peak, and the minimum one was right down the other end of the time series, and it actually is, you're looking for the lowest peak, and it actually comes out at 13.11. And this is why it's tricky with lots of months, because you want the lowest peak. There's a lot of peaks in between, or a lot of other so you can see a 12.48. Well, that's not the lowest peak, but it also might be a value just next to the lowest peak. Okay, I've done this before you walked in the room, so I know it's actually 13.11. I wonder where it is. Yeah, anyway, I've chosen a tricky one. There it is. 13.11. I've chosen a tricky example. The ones that you're doing are only quarterly data, so it's easy to find. So remember, 13, if you had a calculator handy, and let's just do it. Okay, calculator. Menu 1. 13.44 maximum peak minus the minimum peak 13.11. Okay, that's the difference. Only a 33 million kilometre squared drop in area as a fraction of the original value 13.44. Execute. Multiply by 100. 2.5%. And if you look on page 19, the peak value change or percentage change says minus 2.5. That's telling you it's a decreasing trend as opposed to a positive trend. And I think the way they must have done it is they must have gone min minus max, but it's still the change, and you end up with a negative percentage if you went min minus max.